Hello and good afternoon friends, welcome to CEC EduSet live lecture. Dear friends, in this session today we are going to discuss on what fly ash is. You might have heard about this term, or if you not have ever heard about this term, you are going to acquaint with it, because today we are going to discuss about it in detail. And for this we have again with us in our studios Dr. Arun Srivastav. He is an assistant professor in School of Environmental Sciences, JNU. As well as I would like to tell you all that he has done immense research on air pollution, as well as air pollution is his core area. He acquaints, or we can say that he impart knowledge basically in the area of air pollution to his students. So with his experience as well as through his research work, I hope that today we are going to learn a lot through him. So first of all, I would like to welcome our guest Dr. Arun Srivastav. Hello sir, welcome to the EduSet lecture, and in previous lectures also we have tried to learn such much from you that we feel that whatever we haven't learnt in the area of environmental science, it becomes possible through you. So as per our topic is fly ash, I basically want to know from you what fly ash is.
Okay, thank you very much. Good afternoon everyone. So the topic of today is fly ash. I think many of you would have heard about fly ash. Fly ash, just as far as its definition is concerned, initially it was also known as flue ash. It is basically one of the residues generated in combustion and comprises the fine particles that rises with the flue gas. Flue gas is basically the product when the coal or any other fossil fuel is burned, especially in the industrial processes, whether it is some kind of industry or it is a thermal power plant. Here you can see the different pictures of fly ash. One is mound, and this is a kind of a collecting site of fly ash. The first one, the top one at the left hand side, while the second one is it is a close picture or zoomed in picture. It is a pile of fly ash again. The third one, or the bottom left picture, is basically a magnified picture of fly ash. It is being taken with the help of scanning electron microscope. Here you can see the spherical particles, very smooth spherical particles. These are basically carbon particles, and some aggregate particles where they are not actually the sphere in shape, but their particles are there. Some irregular shaped particles are there. Basically they are silicate or other metallic particles. And one more picture which is at the right hand side, bottom right hand side. It is further zoomed in picture. We can say that this actually gives us the detailed description or detailed visual picturization of the individual particles. So again, coming back to the fly ash, what fly ash is actually, as far as this definition is concerned, ash which does not rise in is termed as bottom ash, and it is in an industrial context. Fly ash usually refers to as product during combustion of coal. Basically fly ash is a product of combustion, and primarily the pulverized coal. Pulverized coal is basically, it is a kind of, basically we can't use the coal in bulk when the power plant or in any industrial process. But what do we do? Before burning it or before utilizing it, we have to crush it in fine size particles depending upon the need of that particular industry, and that is known as basically the pulverized coal. And the burning of, or this can also be produced with by burning of residual oils in large industrial power boilers. And how it is formed? Actually, when the pulverized coal is burned, fly ash is formed. The fly ash formed from the incombustible component of the coal. Chemically, more than 85% of the fly ash is consist of aluminum, silica, iron oxide, lime or magnesia. As the ash particles leave the furnace, they are suspended in the flue gas and considered as industrial aerosol. That is why this is a kind of environmental hazard, especially the air pollution. Especially that is why it is called a very hazardous air pollution. After fly ash has been separated from the flue gas, it is found that in the bulk state, the ash can vary greatly, having a wide range of particle sizes as well as its chemical composition. Fly ash, since it is widely diverse in physical and chemical properties, so it is very difficult to actually understand and utilize it properly in any other requirements. Now, how the fly ash is formed? This is basically the flow chart of that entire process, or how it is after formation, how it can be utilized. You can see it starts from the coal source. Coal is pulverized or it is crushed to fine particles, then it goes to the boiler. From boiler it goes to the production of, it is basically utilized for the production of electricity or any other kind of industrial need. And from there it goes to the electrostatic precipitator. Why this electrostatic precipitator is required? Because the fly ash, the portion of fly ash which can't be settled naturally, then in that case we apply a kind of instrument that is known as electrostatic precipitator, which actually with the help of charging of those fly ash particles deposit it to the surface or at the bottom, from where it can easily be separated. So through the ESPs we separate the particles or we collect the particles. From here it goes to the transfer system. So one is dry, another is wet. How the wet comes? Because electrostatic precipitator which actually collects the particle, it collects the particle in dry form, but apart from that there are particles which are larger in size. They can easily be separated by wet processes or by spraying the water into it, and that is why it is known as wet fly ash. So now we have two different type of fly ashes. One is dry and there is wet. So the dry fly ash goes to the storage, from where it can be either utilized or it can be disposed of as the requirement or as the need is concerned. And the wet fly ash, it goes to the ponds, from where either it is stocked in stockpiles or as far as need is concerned, it is utilized depending upon the need. This is a picturization of the same process what I described in the previous slide. So you can see here the coal is pulverized, and from there it goes to the boiler, and from the boilers it goes to the different, there are chains of electrostatic precipitators or bag houses. There it is actually settled to the ground, or it is actually separated from the flue gas. And here it is worth to mention that some of the fly ash is collected from the boiler only. I mean, they are these are the fly ash particles which are larger in size, so they settle there only, and from there it can be collected. That is why it is also called as bottom ash. It forms the portion 10 to 20%, and while going from boiler to the electrostatic precipitator, some of the fly ash is again separated. It forms actually 1 to 5%, and remaining 70 to 90% is separated with the help of electrostatic precipitators. This is again a complete picture of the same process. Coal is taken from the stock or store where it is stored, and there it goes to the pulverizer, then boiler. We can see here the yellow color, it represents the flame which is generated for the production of electricity. And again there are two methods how the fly ash can be produced. One is through the flue gas which goes to the top or through the top of the boiler. Another is bottom ash which is disposed immediately at the boiler. So there it can be removed, and the remaining which goes with along with the flue gas, it goes to the precipitators. This again a same kind of picture. So it is also a kind of descriptive kind of picture. Here the same process, everything, and the process of electricity generation is also shown. Now, here in this picture from the collection hoppers or from the electrostatic precipitator, the wet and the dry fly ash is collected, depending either it can be collected for the stocking or it can be collected for the utilization. Now, I must give some information about the capturing or collection of fly ash from the flue gas, how the fly ash can be captured. Fly ash is generally captured, as far as its removal from the gas stream is concerned, is captured with the help of ESPs or the electrostatic precipitator or other particle filtration equipments before the flue gas reaches to the chimney, because once it reaches to the chimney, from there it can't be separated out. It is bound to go to the atmosphere, and that is very much dangerous for the environment. And sometimes water spray is also applied for the removal of fly ash particles, and this water spray method is applied when the particle size are large enough to be collected with the help of water spray. Now, here in this picture, if detailed picturization of the fly ash formation is given. There is a bulk at the left hand side, bulk coal is there. This is converted into, it is pulverized basically, or the coal matrix is formed. Then this YAM is basically the gaseous form of fly ash, and from here it is 1 ms which is combined with the water, and that is basically wet, that is in orange color, wet fly ash, and it is collected or stored. Another is through the electrostatic precipitator, etc. So, this is minute description of the at very small level of the fly ash particle, how it can be separated or how it can be collected. Now, another important thing, what could be the composition of fly ash? The major compounds or major components of fly ash are silicon dioxide, that is SiO2, and calcium oxide. Both are amorphous or crystalline, they are never crystal. So, here one more thing I would like to mention, that the fly ash, as far as the composition of fly ash is concerned, it is not fixed always. It mainly depends upon the type of coal, because all we know that coals are of 3 different types. One is bituminous, subbituminous, and lignite. So, depending upon the type of coals what we are using for that particular industrial process, whether it's a thermal power plant or any other industry, the components are decided. If it is bituminous, then the silica content varies between 20 to 60%. How this significant variation 20 to 60% is? It's a matter to be to think about. This 20 to 60% is because of the age of that particular coal, how old it is. So, depending upon the age, this silica content or any other chemical component varies in a particular type of coal, and if the type of coal varies, then definitely the chemical composition vary. So, the major components are silica, which forms the major part of any type of coal, then aluminum oxide, then iron oxide, then calcium oxide, and some of the fly ash is lost during the ignition, and that is also sometimes significant. It can vary from 0 to 15 in case of bituminous, it can vary from 0 to 3 in case of subbituminous, or it can be 0 to 5 in case of lignite coals. Now, furthermore here, this is compared with the red mud. This fly ash composition is compared with the red mud. How the components are different from the red mud. We can see silica is significantly higher in case of fly ash than that of red mud. Red mud is basically the soil what we find on our earth, again more or less, but iron component is definitely more in case of red mud, as well as aluminum oxide, because in earth crust these two elements are significant amount. Apart from these, what I earlier mentioned, silicon, ferric oxide, aluminum dioxide, and calcium oxide, we can find other components. They are magnesium oxide, sulfur oxides of sulfur, sodium oxide, potassium oxide, and again the loss of ignition. Here sodium oxide, potassium oxide and loss of ignition are usually in very significant amount. They are either around 1% or less than 1%. As far as some physical properties of fly ash is concerned, we can say that glass content of fly ash is around 43% in total, and the major crystals what we can observe in fly ash are quartz, mullite, hematite. Here again, apart from those what I mentioned, some more components or chemical components are given. There P2O5, some water is there. Apart from there, some trace elements are also significantly observed. They are arsenic, copper, molybdenum, nickel, lead, strontium, barium, chromium, zinc and cobalt. So among these metals what I mentioned, some of them are lethal, they are toxic, and basically they are arsenic, beryllium, boron, cadmium, chromium, chromium-6, cobalt, lead, manganese, mercury, molybdenum, selenium, strontium, thallium, vanadium, some dioxin as well as some PAH or polycyclic aromatic hydrocarbons. They are very harmful, they are known carcinogens. Similarly, dioxins are also known carcinogen. They are very injurious to the health as well as to the environment. It is not that toxic compounds are always fixed. The composition of toxic compounds in fly ash varies depending upon the from where we are getting the fly ash. So here in this particular picture, the different fly ash, the green one is the fly ash which is at the lithosphere, as well as the purple shows the fly ash which is generated as a waste from any industrial process, and the gray one is of bottom ash that was actually generated in the boiler only, and the red one is from the filter ash. So here this picture we can see its variation in composition from for different seven toxic metals: lead, mercury, antimony, cadmium, arsenic, zinc and copper. The significant component is lead in all the cases, as well as zinc and copper. The lesser amount of metals what we can expect in any kind of fly ash, in all the different 4 types of fly ash, are mercury, antimony, cadmium, arsenic. But they are present, and even sometimes this trace presence or even very small amount of presence becomes very significant as far as the human health is concerned. Now I must show you in this particular picture the XRD pattern of fly ash. XRD basically is done to determine if in any sample whether some kind of crystals are present or not. Here in this particular picture we can see the peak is observed for quartz. So the quartz which are found in all the 3 forms, crystal, crystalline and amorphous, are significantly found. So in this way we can also confirm that the content of quartz is more or less always maximum in any type of fly ash. Here again the same kind of picture is there, but at different 5 temperature, starting from the temperature at freezing point to 1000, 1200, 1300 and 1400 degrees centigrade. More or less in all the cases we find that the crystal structure is only observed in case of quartz. Now as far as the size of fly ash in comparison to other different pollutants, atmospheric pollutants are concerned, here in this picture you can find the smallest picture is black carbon or fumes of zinc oxide or smoke or metallurgical fumes, and the maximum is the limestone, and the sizes are given in micron, basically micrometer. Here in the coal ash or fly ash, size varies between around 1 micron to about 100 micron. So it is in the mid of all the atmospheric suspended particles which we can expect in atmosphere. Now again, as far as the size is concerned, different 7 samples were taken of fly ash from different places, from different industrial processes, to observe or to find out what could be the size range of the fly ash particles. So it was found that the maximum size is always over 100, but it is always less than 300. So in one case, even the size of particle was around 212 micron, because a sieve was the different sized sieves were arranged. Their sizes were selected: 300, 212, 160, 106, 75, 55, 45, 40, 20, 15, 15, 10 and 5 micron. So in case of one of the samples, it was found that the sieve, which has the size range of 212 micron, it passed around all the fly ashes, I mean 100%. So we can see, we can say more or less the fly ash size sometimes, although it can go to over 100, but generally it varies from 100 or 150 micron to up to 1 micron. As far as the median size is concerned in micron, it is, the variation is between 12 to 2.1 micron in various samples. Surface area might vary from 2 to around 1 meter square per gram. Brightness is also given here. It can vary between 86.4 to around 82. Oil absorption capacity is concerned, as far as oil absorption capacity in gram per 100 gram is concerned, it can vary from 27 to up to 29. Moisture content is not very much, it is very less, because it is already coming through a furnace or from a firing after going through fire. So it is very less, but there is some kind of, there is some amount of moisture is definitely present. It is it can vary between 0.17 to around 2.0. And other physical properties are concerned, some pH is 6.6. So basically we can say that it is of neutral character, it is neither acidic nor basic. As far as its refractive index is concerned, it can vary between 1.54 to 1.55. Hardness is 6.5 moles, whilst specific gravity is 2.65 gram per cubic centimeter. Now the type of fly ashes. There are different two type of fly ashes. As far as the America's nodal agency, which actually govern all these material things, the American Society for Testing and Materials, ASTM, have classified fly ash in different two categories. One is class F fly ash, another is class C fly ash. So now what is class F fly ash? Basically class F fly ash is obtained or is generated when we burn harder, older anthracites or bituminous coal, then the F type of fly ash is produced. This fly ash is basically pozzolanic in nature and contains less than 20% of lime. Pozzolanic means the cementing character, I mean it has some cementing properties. Then possessing pozzolanic properties, the glassy silica and alumina of class F fly ash requires a cementing agent such as Portland cement, quicklime or hydrated lime with the presence of water in order to react and produce cementous compound. Alternatively, the addition of a chemical activator such as sodium silicate, water glass to class F fly ash can lead to the formation of geopolymer, that is again a very important and very useful kind of building material. Now what is class C fly ash? Class C fly ash is basically produced by burning the younger lignite or subbituminous coal. In addition to having pozzolanic properties, it also has some self-cementing properties. In the presence of water, class C fly ash will harden and gain strength over the time. Class C fly ash generally contains more than 20% of CO. Unlike class F fly ash, self-cementing class C fly ash does not require an activator. Alkali and sulfate contents are generally higher in case of class C fly ash. Now, its composition. Here we can see that, and a comparative or a comparison with cement is also given. In case of class F fly ash, the silica content is more than that of class C fly ash as well as than that of cement. Similarly, aluminum oxide content is also significantly more than that of C class or cement. Fe2O3 content or ferric oxide content is in both the classes, whether it is F or C classes, it is roughly more or less equal, while in case of cement it is more. As far as lime is concerned, the part of lime in class F fly ash is very less than that of C class fly ash, and it is further less than that of cement. In case of cement, the lime content is over 60%, while in case of C class fly ash it is around 25%, but in case of F class fly ash it is less than 10%. Similarly, magnesium oxide content is more in case of C class fly ash than that of cement or F class fly ash. As far as oxide of sulfur is concerned, it is again very less in case of F class fly ash than that of C or cement. As far as oxide of sodium and potassium is concerned, it is again less, further less, but moisture and loss of ignition is equal in both the cases, whether it is C class fly ash or it is F class fly ash. As far as alkali is concerned, it is again equal, it is 1.5%. Some physical properties, the comparison of some physical properties in both the classes, whether it is F class fly ash or C class fly ash. As far as fineness, strength, water requirement, autoclave, etc., and density or fineness point is concerned, more or less all the physical properties are same in both the cases, whether it is C class fly ash or F class fly ash. Thus, we can say that in both the cases, C class or F class fly ash, the significant variation happens in case of chemical properties, but not in case of physical properties. Now, the implication of fly ash, how it can affect, what type of effect it can give. So here in this particular picture, it more or less it can represent all its negative or positive aspects. So it starts from the central point where it is ash amount, where the fly ashes are collected if it is not transferred to some other place or to the utilization point. So it can reach to the air. What happens if it reaches to the air? Through wind transport, etc., it will become the part of atmosphere, and after some times with the help of rain or etc., it will reach to the surface water, and from there ultimately it can go to the groundwater aquifer. And why we are concerned? Because already I have shown that the fly ash may contain significant amount of toxic compound. Thus, it's where it is collected or stockpiled, one has to be very careful that either it shouldn't go both the direction, it shouldn't go to the atmosphere upward, or it shouldn't go to the downwards or in the reverse direction, that is in the ground, because both have very serious and harmful implications. So if it is on one hand it can go to the air, on the other hand it can go to the surface water as well as to the surface soil. What happens when it goes to the surface water? From surface water, ultimately it can reach to the underground water. If it goes to the surface soil, it can reach to the deep soil, and from there, from deep soil, it can ultimately become the part of underground water. And from surface soil or surface water, both are reversible process. I mean, surface water, it can go to the surface soil, or surface soil, it can go to the surface water. And where these surface water or surface soil have harmful effect, it is for the farm. It is for farmers, because if the soil is spoiled, the farming becomes very, very difficult. Once it becomes a part of surface soil, from there again over the time or in due course of time, through the wind transport, it can again go to the atmosphere or air, or it can again from there reach to the deep soil, and from deep soil it can go to the underground. So in this beautiful picture, everything is I mean, it represents a very informative or systematic information about the fly ash, what effects it can give to all the different components of atmosphere, whether it is air, surface water, surface soil, underground water or deep soil. Now, what are the environmental implications of fly ash? So, this is a very important air pollutant because of its toxic composition. It can contribute to the acid rain. It has global warming potential because of its composition. It has significant role in radiation budget. It also plays a very important role as far as visibility is concerned.
So, sir, you explained in detail how these fly ashes are produced and what are its implications, their composition. Now, my question arises, does the fly ash produces only after the combustion of coal? It is the only source of production of a fly ash?
Yes, but sometimes they are naturally found also, especially in case of volcanoes. If we are in the vicinity of volcanoes, although it is very, rare in India, except some places of Andaman and Nicobar Island, but in other countries like Hawaii and Italy and Indonesia, there are good number of volcanoes, and some of them are very active. So they are also a significant source of fly ash. And what happens if rain etc. are not there, and if the condition or the environment is very dry, so these fly ashes keep on accumulating somewhere, because no one can go during the when the volcano is active. So it keeps on accumulating, and since the environment is dry, what happens? From there it can easily be transported to the other places. So in due course of time, it can become the part of atmosphere, it can become the part of underground water, it can become the part of ground, soil, or it can become the part of surface water. And again, in the previous picture as I showed, from there it is again linked. Air is linked to the surface water, and surface water is linked to the underground water or the deep soil. Similarly, soil is linked to the air. So it is a very linked process. So from anywhere it can go to the other place.
That is, we can't say that it is only limited to the air pollution, because the environment works in a cyclic process.
Yes, it is a kind of cyclic process. Yes, and so over the time we can't say that this might contribute more or this might contribute more. If the source of fly ash is there, it can have a very significant impact on all the different 4 or 5 dimensions of the environment, and those 4 or 5 dimensions are interlinked.
As you also explained and used the term acid rains in between, how fly ashes are connected to the acid rains?
Yes, it has some compound, like it has one in one of the when I showed the table of its composition components, you saw it also contains oxides of sulfur. Oxide of sulfur is very reactive depending upon its temperature etc. Once it comes in the contact with water, the chances are there that it can form sulfuric acid, and that sulfuric acid over the time can become the part of rain, and that is why it is somehow can be linked with the acid rain.
So, if we are talking about the acid rain and we are connecting it to the fly ashes, number of times we have seen in the newspapers that the monuments which are deteriorating because of the pollutants which destroy the monuments. Does fly ash plays any role over there also?
Yes, it has a very significant role. Fortunately, you know, the government or the nodal agencies are very careful that the fly ash shouldn't go into the atmosphere, because I already told you that very less amount of, maybe 1% or less than 5% of the fly ash can go into the atmosphere or can become the part of air. Most of the fly ashes are removed in one or the other processes. So we, in this way, we actually stop its migration from one place to the other, even though if the processes are not very active or not very strong, so it is possible that it can become the part of atmosphere, and in due course of time, wherever it reaches, whether it reaches to the farm or it reaches to the monument or it reaches to the lungs of human, it plays a very negative role.
So, what are those processes with the help of which the fly ashes can be controlled or stopped? Are there any?
Yes, I told you there are different 3 processes, because what happens, the coal is first, as I already described, coal is pulverized, I mean it is crushed to the fine particles so that its surface area is increased and we can get efficient burning. So first the coal is pulverized, from there it goes to the boiler where it is heated or where it is used for the heat production, and the water is boiled, and that steam is basically used for the generation of electricity. So what happens, some of the fly ash, around 5 to 20% of the fly ash can be removed at the boiler only. And how it can be removed, it is just a very normal mechanism. Some of them are burned and some of them, those who are finer, very fine, that they can't sustain to the boiler, they are removed, but they are not very fine to go with the gas or with the gas stream. So medium sized particle there are removed, and the final particle which goes through the gas stream, they actually reach to the different electrostatic precipitator. There should be chain of electrostatic precipitators. Electrostatic precipitator, what does it do? It has some specific kind of charge, it could be positive or negative. What happens when these particles or fly ash particles come into the contact of these are plates basically, these are metallic big plates. When it comes into the contact or when it comes near the those plates, charged plates, what happens, a opposite charge is induced to those particles. Suppose the plate is a positive charge, and once the particle flows through those plates, it will become negatively charged. So once negative and positive, they are attracted, and the fly ash particles are accumulated on the plate, and from there it can be removed. And apart from this is one of the mechanism, electrostatic precipitator. Somewhere filters are also used, some strong, but these filters are not normally used in case of power plants, but they are used in case of other industrial processes, because fly ash is not only produced at the power plants, but many industries which use the coal or some other fossil fuel as the source of burning. So they are also produced there. I mean, where the production of fly ash is not very much, there some kind of filters are also used. It's a simple filtering mechanism. The air is passed through those filters and the particles are stopped back, and the clean air is passed away. So this is how the fly ashes are removed. And the third process is by shower. Those particles which are of medium size, not very fine, they, with the help of shower, spray of water, can be, I mean, this in one of the pictures I showed how it is done. A matrix is generated. I mean, the fly ash is sprayed by water, and once it becomes wet, and after becoming wet, if they come into the contact of each other, they fall. After drying enough, they fall at the ground. From there it can be removed. So these are the different three mechanisms how the fly ash can be removed from any fly ash production system.
From the fly ash system production, but in case, sir, if some of the amount is basically liberated into the environment, and specifically if you talk about all the monuments, for example, if you talk about, for example, Taj Mahal or any monument in Delhi also, so can there be any alternative to protect those areas?
Yes, it should be cleaned regularly, because that is the one of the, it should be cleaned, either it should be wet cleaning or it should be dry cleaning. So once it has to be established that whether the fly ash is reaching there or not, because once the fly ash is reached, it is bound to do some harm. So our aim should be, first to establish that whether the fly ash is reaching to that particular monument or particular human habitat. So if it is reaching there, we will have to be careful. We will have to arrange for its systematic removal. If it is reaching to the monument, it has to be cleaned regularly, either through water spray or some kind of cleaning mechanism, like dusting, etc. It can be cleaned.
You use the term pozzolanic properties.
Pozzolanic properties.
What are basically these properties are?
I think I mistakenly said it wrong. Pozzolanic properties means that it should not have some kind of cementous character. If it has cementous character, I mean cementous character means, suppose if we put some water into it, the particles will be attached with each other. That is known as cementous character. So one class, that is F class, it is not having pozzolanic property. So because nowadays in India the maximum consumption of fly ash is being in cement industries. So if it has some pozzolanic properties, means we'll have to add some non-pozzolanic material or some cementous material so that it can efficiently be converted into the cement. If it is having non-pozzolanic properties, it means that we don't need to put a significant amount of cementous material.
That is basically the classification,
yes.
which can be converted into cement and which cannot.
Yes. Yes.
Sir, now another term you used, autoclave. What this autoclave is?
Autoclave, actually, autoclave is basically for the cleaning of anything. I mean, autoclaving, you can say that suppose if we'll have to make something free of any biological contamination, etc. So we imply autoclave. So in that particular thing, because autoclave is a system in which, with the help of steam, the biological or pathogens, harmful pathogens are killed. So it is free from any bacterial or viral or fungal contamination. So autoclaving is.
And sir, you also used XRD patterns of fly ash. It is regarding what you was trying to say.
It is basically just to establish that if there is some kind of crystals present into the fly ash or not. So in that particular XRD is actually stand for X-ray diffraction. So what happens, and XRD is an instrument which actually determines that if in any sample we have some crystals or not. Crystal means developed phases. So in this particular case, in case of fly ash, the maximum amount of crystal which are present in this are what? So XRD is to determine that crystalline structure, crystal or crystalline materials are present into the sample or not.
Okay. Sir, as you said that there are different types of coals. Basically you mentioned about, I think, 3 types of the coals.
Yes.
So if we burn each coal at different temperatures, then the quality, we can say, or the reactivity of this fly ash would change?
Not really. In case of we need a fixed amount of temperature. So whatever kind of coal we use, we will have to obtain that particular temperature so that the water can be boiled and the steam can be generated for the production of electricity or in any other industrial application where the coal is required. So depending upon the nature of the coal, the pollutants or its efficient burning is determined. If it is not a very good coal, so definitely it will create more ash. I mean, it will have, so there are 2 things, if it generates more amount of ash, so it is giving less amount of energy. If it is generating less amount of ash, then it is giving you more energy. So the difference is here. I mean, if like anthracite or bituminous coal, they are basically older coals and they are having much energy, lesser fly ash, but peat etc. are sub-bituminous, they are having more amount of fly ash or waste material than that of energy. Our aim is to anyhow receive the energy, maximum amount of energy. And why we are bound to use any type of particular coal? Because it depends upon the availability. Whatever coal is there, we will have to use that particular coal and let the waste be generated. But our aim should be that the waste which has been generated, it should not go waste. It should be utilized, or it should be in such a, it should be disposed in such a manner that over the time it can create some harmful effect.
But sir, when you explained about its toxicity, or if we say that the composition changes, if we talk about the particular coal,
Does
the toxicity changes?
Yes, it depends upon the type of coal. The composition of different toxic metals vary. I mean, if although it is in trace amount, but even the presence of toxic metals is very important or very alarming. So that is why I said, because our aim should be whatever type of coal, even it is trace or even it is lesser in comparison to the other type of coal, but it has to be properly disposed of, because those toxic metal, if it becomes the part of atmosphere or it becomes the part of underground water, it is bound to create harmful effect.
And if we talk about the health hazards caused due to this fly ash, what are those health hazards one can predict?
You know, it has many type of health hazard. Number one, if it becomes the part of atmosphere, then definitely it is going to cause the human health hazard. Like it can be n number of health hazards. The maximum or the major impact portion will be, breathing troubles or respiratory ailments, starting from asthma, bronchitis, sinusitis, etc., etc. And depending upon the toxicity of those fly ashes, it can even, in due course of time, it can even create the long-term diseases. I mean, it can be lungs cancer or some other diseases which are very, very chronic and dangerous. Apart from that, I told you it is when it is the part of atmosphere. Once it is the part of underground, so it is bound to leach to the underground water, and a good number of people, more or less everyone, depends upon the underground water. So depending upon the toxicity of the fly ash and the porosity of those that area's soil, if a significant amount of toxic metals are becoming the part of underground water, definitely it is going to create other type of harmful effects to the human being. I mean, definitely it will be related to the lungs or waterborne diseases, long term, short term, chronic, less chronic diseases. If it is becoming the part of soil, definitely it is going to reduce the fertility of the farm. So it will, it can definitely alter the pattern of crops. So we'll have to be careful in all the different aspects of fly ash generation, that it should go to any of the component of these systems.
That is, we can say that it is harmful for human beings, for soil, that is fertility of soil, that is for the plants,
yes,
as well as to the human beings, as you said.
From the groundwater.
Sir, humans are more susceptible to the skin kind of diseases. If any pollutants are there in the atmosphere, it hampers the skin also. Does these fly ashes hamper the skin?
Definitely it might create the harmful effect. If one is, it is a kind of occupational health hazard too. I mean, those people who are working in the fly ash, or those who work in the fly ash stockpiles, or they are in the process of that thermal power plant or electricity generation, if they are part of that particular system. So they are definitely, if they are not very careful, if they are not using the precautionary measures, then definitely they will have certain kind of skin diseases.
Sir, what is that major big difference between the class C fly ash and the class F fly ash?
It is mainly because I told you that one is pozzolanic nature, another is non-pozzolanic nature. Because in India, the largest consumer of fly ash are the cement industries. So if it is having a pozzolanic properties, then definitely we have to process, or we'll have to put some cementous material into the fly ash to make it to the cement. If it is having non-pozzolanic properties, then the requirement of cementous material will be very, very less. Or we can say that it is ready to get converted into cement.
Sir, what about the coals which is used in the household purposes for basically for burning? Does these coals also produces fly ash?
Definitely, you know, any kind of fossil fuel burning, although if it is petroleum etc., they do not produce fly ash, but the coal or even the wood etc., definitely it produces fly ash. But fortunately, the burning of fly ash is the burning of coal in domestic processes is very, very less. It is very less. So, and it is so less that it is very nicely removed by the person who uses this. So it doesn't affect. I don't think that it creates much harmful effect.
So regarding this also, it might be my confusion also. The people who used to cook food, and for that they burn coal. So in that case, does that coal also harmful, or does it produces fly ash?
Fly ash is basically, you know, fly ash is the byproduct. I mean, when the coal is burned, then this fly ash is generated. So in the cooking etc. processes, there is some distance between coal and the pot on which the food is being cooked. So, and you see in the same kind of the same process is there in case of boiler. What happens, the fly ash, which is also known as rock, it actually falls down at the bottom, giving the energy to the upside. So from there it is the chances are very less if it is not very windy and that furnace or the chulha is not proper. So then only the fly ash or the particles can get into the food item. Otherwise the chances are very less, and even if it is in very small amount, very small, I don't think that it will create much harmful effect. But the regular exposure, or if we are regularly exposed to the fly ash somehow, then definitely in due course of time it might create very harmful effect.
So basically we can say that the fly ash, if it produces, it first of all disturbs the environment as well as the human beings, plants and other beings present on the earth. So sir, we have very less time left with us.
One more thing.
Yes, sir.
I would say that the best part of the fly ash is that it is very useful. So in next class we will discuss it, because a good portion of this is left. And now this the concern of fly ash will be over, because although we just saw the negative part of results or negative implications of the fly ash, but it's some very good effects. I mean, it is very, very useful. That we will discuss in the next class.
You have laid a very important point over here, and we are curious that tomorrow what else we are going to discuss regarding this topic, when we have discussed about the negativity of fly ashes, why they are advantageous, how they are advantageous. We'll be discussing on all this on this particular topic, and I would like to tell all the students that Dr. Arun Srivastav would be again with us, and we would be able to learn more through him. I hope that. Thank you, sir. Thank you so very much for being with us.